Okay, fine. Okay, so last class we started talking about data cleaning. Again, data cleaning was this idea that, actually, where are we up to? Right, data cleaning is where we basically started. Data cleaning is this idea that when you get in, most data sets you're going to be dealing with are going to be messy in some way. Okay, and that there's a fair number of fairly common and fairly routine problems that are necessary to take your data set and refine it to the point that you can kind of believe the results from it. Yeah?
Maybe we're going to go over, I guess we're going to go over imputation, but we sort of talked about it last week, and I just had a question after I thought about it a little more, which is like, I don't understand how the imputation using a mean or median value for the,
Yeah.
how that adds anything beyond.
Okay, so hold that question. We're going to talk today about missing values. And so your question is, why should we do it, or something like that. We'll talk more about it, but basically, there's certain values that are missing that if you treat them the wrong... Okay, a lot of analyses in a data science thing, for example, will revolve around trying to recognize similar things. Okay? So maybe given two records, which ones are similar. Okay? And if one is missing a value, and a field, and you replace it with a completely ridiculous value, you will end up with something that is not a similar record coming back as being a close one. Okay? So for a lot of... Or another thing, when you're building a regression model, let's say that we're building a regression model. And again, I should probably talk about it when I talk about missing values. But remember, in a regression model, you're building some function of the input variables to predict some y value, right? Suppose, let's say, one field was missing. Okay? Now, in principle, you can, on a particular record, you want to make a prediction and one field is missing. You can't automatically use that function unless you have a value for that. Does it kind of make sense? It's got 7 inputs. If you give it 6 inputs, you can't run, right? And if you put a value here that is wildly far away from the other values in the model, you can come up with a completely weird answer, okay? And so in this case, if you put in a mean, let's say, you're kind of saying, well, it's not that, for me, don't make too big a decision based on that, right? If we had a life scale model and, we're trying to figure out how long you're going to live, and there's several factors in here. If we didn't know whether you smoked or not, if we put in that you smoked the average amount, that's good, right? If we put in some number that got interpreted as smoking an infinite amount, okay, then that would wildly change the prediction, right? So that's kind of, I guess, one reason why imputation is so important. Okay? Any questions? But we'll get to that. Okay? So there's several things that we're going to be doing in here. I started last time talking a little bit about this notion of telling errors from artifacts. But there's several steps that get involved in cleaning data sets. Particularly, some of these particularly involve in integrating data sets. Quite often you're going to be given data from a couple of different sources and mash them together. And the act of mashing them together is, I would say, somewhat of a cleaning step. And if you mash them together in the wrong way, you get garbage. And if you mash them together in the right way, you get wisdom. Okay? And that's why these cleaning issues are kind of important. Any questions about that? Okay, so that should be believable. We talked about this notion of errors versus artifacts last time. Did everybody kind of get that idea? That errors are things that come from your data, and artifacts are something that comes from you. Okay? And, and you've got to be aware when you do some of these data processing. We'll talk about visualization later in the semester. But whenever I have a data set, especially one that was put together by mixing sources and stuff like that, you definitely want to look at plots of it. You want to look at this data to really think that you believe it. My assumption is most of the time when you do an operation on data, integrating it or doing something, you have done something wrong. And you need some way to validate it other than a summary statistic at the end. Quite often people will take data, they'll compute the average of it, say, look, the average is right. But you really want to see what you did, and that's why taking a look at a plot is important. And as we showed last time, often you can look at a plot, decide whether the distribution of what you're seeing is what you think you want to see. And if not, figure out why. It might be because the data is, in fact, has this characteristic, but quite often it's something you did to it. Any questions about that? This is what we did last time. Any questions? Okay, so I wanted to talk more today about this notion, about some of these other steps. And one of these steps that I want to talk about, an issue that comes up a lot, is what I will call unifying data, finding compatibility. Typically what's going to happen, especially when you're merging data sets, you've got one file here, you've got one file here, probably relevant data that's relevant to each other, but it might have been collected by different people at different times, okay? In order to integrate it, there's often a lot of unification or comparison problems that come up, okay? And it's important to, make sure you correct for these if you're going to integrate something, so that that both data sets are kind of really the same, okay? And so I'd like to go through these kind of classes of things: number conversions, name unification, time and date unifications, things like that, okay? So we know how to massage them. Any questions? Okay. So the first one is one that I think I won't have any hard time convincing that is a problem. Is that if you're collecting data from two sources, and one of the fields is height, okay? Let's say you're building a database on soccer players, okay? And one of the fields on them is height, okay? It's quite often, if you have two different sources, one might be using the English system of feet, inches, stuff like that. One might be using the metric system. And if you try to merge these two sets of data together, you will end up getting something that is meaningless. Okay, that much should be clear. So whenever you're dealing with a data set, you've got to make sure that you stick to a particular system that makes sense. And even if you say, oh, I'm going to make all my numbers in metric, that can have a problem. Sometimes a field could be measured in centimeters or meters or kilometers. Those are all metric. But if you have records, some of which are measuring your height in meters and some of which are measured your height in centimeters, you would get an incomparable thing. Any questions about that? And again, this sounds like an obvious problem, but there are a lot of times in the world where bad things have happened when people didn't properly handle conversion between systems. So there's a famous case of NASA losing a spacecraft because somewhere in there they had data, they were expecting the data to be in English units, and it was given to them in metric units, and so the rocket got confused and blew itself up, okay? And so we don't want that to happen to your systems. Any questions about it? Now, how can you tell when you've got an integrated data set that has some things that were done in inches and some things that were done in centimeters? How would you be able to tell? So let's put it this way. Let's suppose I give you a data of people by height, and I integrated it from this thing. And some of these people were given as height in inches, and some of them were given as height in centimeters. How might you tell that you had a problem? Do people see how this might possibly happen? Let's start out from getting concretely. Could anyone imagine a world where, in integrating things, data by sources, you might end up having a mix of two different units? Okay, how many people can imagine that? You can imagine it. Does anybody else have that rich an imagination? Good. How now might you figure out check whether you have that kind of a problem? Yeah? If you have a histogram, that would be a bimodal distribution, right? Because in inches, the height in inches, you're going to have a lot of people with heights in inches of around 65 or so, something like that, right? And if you had them in centimeters, what's my height going to be in centimeters? 165. Does everybody kind of see that? And so this is one reason why you plot histograms, to try to make these kind of things happen. Any questions? Now, over the course of an entire data set, there's going to be many, many units, right? Again, the particular problem I'm worried about here is you've got one garbage column, right? Another problem that often happens is that you will integrate data by, by, let's say you found a key element in common. You had two records on Skiena, right? You had my employment record and my criminal history, right? And you decide to integrate them into one spreadsheet, right? Now, it might be certain things about my criminal history would be in English system. My other stuff might be in metric system, right? And so it's very easy to think about getting records where you've got a confusion that way, which is a little bit of a different problem, okay? And one way that you deal with these kind of things, which we will talk about more, and I think I've talked a little bit about, were these notions of z-scores. Z-scores are a way to take a column and represent it by, instead of representing the actual values, represent things by how far they differ from the mean, okay? And that's a way to bring things on different scales to be comparable, okay? Any questions about that? I know I will talk more about z-scores next time, but any questions? Okay, good. Another problem that occurs fairly often is what I would say numerical conversion issues. This is probably less for us in this class, but in quite often people are, and maybe it occurs in this class kind of thing stuff sometimes. You will have columns that are going to be a mix of integers and floats. Okay, you could imagine unifying things from two data sets where some people's heights were given in inches, in feet, where they had decimal properties, so that it was a float. Skiena is 5.38 feet, okay, versus integers, okay? And again, trying to get a consistency across that in a column is kind of important. There is another rocket ship that blew up once because of a problem in converting floating point numbers to real numbers, okay? Any questions about that? So again, we need to be consistent. Generally, decimal numbers are better for us to work with, unless they are counts. Integers are counting numbers. Decimals are kind of measuring numbers. Okay? And generally, your data should reflect that kind of thing. Any questions? Sometimes when you see data sets, you will see things broken up into fractional units. Okay? So when we were looking at the baby name data, the baby weight data for one of the projects last year, there was a giant spreadsheet on babies, and baby weights were, for every baby there was a row, and one thing it had was the baby weight expressed by how many pounds was the baby in one column, and how many ounces was the baby. Babies, you may not be aware of it, when you say my kid was 6 pounds 5 ounces, that would mean 6 pounds times 16 ounces plus 5 is the total number of ounces. But usually when people describe the weight, they will say it's 6 pounds 5 ounces. And that's the way it was represented in this data set. And that made it impossible to compare whether one baby was heavier than the other in one thing. Does everybody kind of get that idea? There was a fractional component, which was the leftover ounces, and there was the body of pounds, right? A much more sensible way to do it would be to have it be in the number of ounces, okay, or the number of grams or something like that, total, rather than breaking it out like that. Any questions? Same thing with like feet and inches. You shouldn't have fractional things in it. Fractional things are a hard thing to work with. Any questions? Okay, this you can understand. Now, a bigger issue with normalizing data that people are more likely to run into in this class or in the kind of projects we do has to do with character representation issues. Okay? Many projects that I like to work on and that I'm sure you guys like to work on involve scraping text from the web and doing something with it. Okay? And the problem, of course, is that representing text in a computer requires the use of a character encoding. Does everybody kind of get that idea? And, when I was growing up, it was a much better world, okay? They hadn't invented foreign languages yet. Computers all used 8-bit ASCII codes, okay? Because anything that anyone wanted to write could be written in English, right? You could even use this higher order bit for parity checks in case your computer had a memory problem, right? There were only 127 characters, and so the traditional code for English was something called ASCII, which was generalized into something, I think they call it ISO Latin, okay? A character code that was 8 bits long that encodes all the major Western characters. Does everybody kind of understand that? However, then the world got bigger, and it became necessary to have a character code that would encode all the languages on Earth. I know people in here, we have a lot of people from India. You all come from different provinces where they have different languages. Okay, we see other people from around the world here. So Unicode is a encoding that represents all of the world's characters. Okay? And there's a character standard called UTF-8 that has the property that it represents characters by sequences of 8-bit codes. If you are doing stuff in good old ASCII, these two will look the same. But it's often the case that even in English-style text, there are occasional characters that people will refer to that go outside the traditional 8-bit code. So what is the upshot here? The upshot is that you can imagine taking text from two different sources, maybe spreadsheets with people's names on them, and wanting to unify them by saying, is this person the same as that person? Recognize that if somebody's name is in a different character encoding, you can't match for equality with that, even if they look English-like. Okay? How many people have stumbled across this problem? Okay, not too many. Okay? But recognize that there are many, many different encodings out there. Okay? And when you are working by scraping something, by processing something, you often get problems with these character codes. How many people have looked on a browser or something like that and seen something like this, all these question marks coming up on a screen? How many people have had that happen? Why does that happen? Is it the computer doesn't know the answer, or why are there all these question marks on the web browser? The reason is a character code problem, okay? That there is, in particular, I think most of the time what that happens is your browser is loaded with a certain subset of characters from Unicode, or it's using a particular encoding of Unicode. There's a couple of different encodings, okay? And you're seeing text from a different encoding, and it has a character, and it doesn't know what it is. Does everybody kind of get that idea? Like, here you've got a message where there's a Russian thing with a word Google in it. Google is universal because that's the 8-bit English thing. But Russian characters, Cyrillic characters are outside that. So a large part of data cleaning is, if you're integrating text sources, making sure the character codings are the same. Any questions? Now, if you are like me, which is wrong in this case, you will say, I remember back to the days when everything was 8 bits long, and I will try to force everything into the old character code that I understand. That is bad, because there's always pieces from other character sets in there. The right thing is to force everything into the Unicode sense. And again, Bart Simpson is now telling you that. Basically, UTF-8 is probably the right character code to be aware of. But to be aware that this kind of problem comes up is the critical thing. Any questions? Has anybody ever had any problems from character code issues? You did? Anything worth talking about? Or?
Just if you're examining binary stuff, so you're trying to convert characters to their binary representation, obviously you have to know if it's in UTF-8 or how to interpret the
Right. Yeah.
The database, when you are working on any database, like for example Oracle, it has a specific char set when you install the database, and when you're trying to migrate some data from a different database, the character encodings have to match. Otherwise, you just
That is exactly the problem. And so there, what you're saying is, that, does Oracle complain if you don't have it?
Yeah, I mean, it won't even allow. There is a
Okay, so Oracle will say you can't add this data with the wrong character set. More likely, if you're working with your own programs, no one's going to complain. It's just going to be a mess. Okay? Any questions? So cleaning is fixing character sets as well. Any questions? Okay. Another aspect of cleaning, which is important, a lot of data revolves around names. And names are something that people put down in ambiguous ways. If you look at me on the web, I am referred to as Steve, Stephen, or S, either without a middle name or my middle name or my initials. Or you can Google me under at least 2 different misspellings of my name, as well as that, okay? So to recognize that if you wanted to see how many pages are there talking about me, or you wanted to analyze all the text talking about me, you've got to find a way to figure out that any expansion of this is probably talking to me. So there's a certain level of problem of, given a bunch of data, how do you unify the records on names? Any questions about that? Have any people ever dealt with this in a previous life, this kind of a problem, where they've had data from multiple sources? What was your issue?
Usually the name, like first name and the last name, sometimes it would be first name, last name, sometimes it would be last name, first name.
All right, so sometimes they even reverse this thing. How many of you have ever heard of a comedian named Bob Hope? This is now going to really date me, okay? Bob Hope. He was an old comedian. His name was Leslie, actually. Before it was Leslie Hope. And supposedly when people made him give his last name first, it came out as Hopelessly, okay? And that's kind of what the problem is. You want to say, how do I know that Hopelessly is the same as Bob Hope, correct? Okay. Any questions about that? Okay, good. So what do you have to do? You have to be aware that in unifying large sets of names across different sources, you have to take steps to unify them. Part of it is about finding transformations that will do it. Like sending everything to lowercase is going to increase the likelihood of there being matches. Okay, because lowercase Steve Skiena is the same as Steve Skiena, right? Removing the middle name is probably going to increase name matches. Okay? What's the problem, though, with removing the middle name? Yeah? You will get collisions. Does everybody see that? And so this is one of these worlds where there is a trade-off between, when you're unifying names, sometimes you are worried about there being... you want to make sure that you match anything that can possibly be matched. And you're willing to allow a few Franken people who are half one record, half another person's record, right? Or you may say, I don't want to create any Franken people, okay? I'm only going to merge if it's a perfect thing, but then potentially mismerging opportunities. Does everybody kind of get that idea? Any questions about that? How many people know what I mean by a Franken person? Frankenstein. Remember the movie of Frankenstein when they made the body and they cut him up they put several pieces together? What happens if you take the work record of Stephen Skiena and you merge it with the prison record of, Sam Skiena, who was only written as S, okay? Then you've now got somebody who's a mix of 2 different people. Does everybody see that? And that's kind of the thing that you're afraid of. That would be, I guess, a false positive. You merge 2 people who weren't actually the same, right? This is ideally why you have keys like Social Security numbers to merge on, right? But again, in certain applications, you're worrying about not creating false positives, merging people who aren't the same. That can be a horrible thing if you were talking about merging somebody's prison record with somebody else's employment record, right? Now this person might never get a job again because now whenever anybody looks up on them, it looks like they're a terrorist or something, right? And you've probably heard about these, you obviously hear about these kind of computer errors, right? The downside is sometimes, however, you're in situations where the cost of emerging a false positive is relatively low, in which case you may want to merge more aggressively. Any questions about it? This is part of the cleaning steps that you have to go through. Now, one thing that sometimes helps with merging are what we would call phonetic hashing methods. Has anybody here ever heard of Soundex? Has anybody ever heard of Metaphone? Okay. What are these? There's some relatively old, but still I think relevant ways to try to take names and replace them by something that will sound the same. Okay? So Soundex actually dates back to like the 1920s when people were filing cards and filling out name forms when they couldn't spell anything like that. You could imagine taking a name and doing certain things to simplify it. For example, you might want to remove doubled letters. Doubled letters are often a source of misspelling, right? So whenever we have double letters, let's remove them. Okay? C's and S's are often replaced by each other because they make similar sounds, right? So for the code for this thing, maybe I will replace it by, if I start with either a C or an S, I'll replace that with a C. And it's these phonetic hashing methods take as input a name and as output reduce a simpler name with the hope that when you collide, let's say, hash people by these simpler names, if there was a misspelling or something like that, these people will lie in the same bucket. Does everybody kind of get that idea? So these things would be designed to replace what it's written by something analogous to how it sounds. And if you can do that right, you might get names collide that you wouldn't have if they were badly misspelled. Okay? So this is another technique that you might use in cleaning to do that kind of thing. Any questions? Yeah?
Wouldn't that increase the false positives?
That will increase false positives at the cost of removing false negatives. So would I want to use that as enough evidence to merge prison records with somebody? The answer is no. Might I use that to cut down a spam mailing list so I don't send it spam, maybe the cost of sending, of falsely merging two people, okay, before I send them spam, that might be a lower thing, okay? So again, the issue here is what the cost is of false positives versus false negatives. Any questions? Okay, fair enough. Now, another aspect of cleaning that turns out to be problematic, okay, and in certain applications very critical, has to do with unifying times, okay? So fairly often you might have database systems. You're integrating various data sources. They each come from computers with different clocks on them, right? You'd like to interleave the events so that they were, so that you know what happened before something else. This is often a pain in the neck, okay? And one issue is that times tend to have, different time zones. There's things about daylight savings time, different other things. You should be aware that there is a universal time standard, okay? That it used to be basically Greenwich Mean Time, kind of when you wanted to unify time events from different periods. Originally, there was one place in the world, the observatory at Greenwich, that was set to be the world standard for where times were. There is now a somewhat more general time standard called UTC that is sort of meant to be a global time standard, okay? And one way to minimize, let's say, confusion about events is to map every event to that time zone. Any questions about that? But there are all kinds of interesting things that happen when you try to integrate data from different scales just because of how time works. For example, does anything look unusual about this month? Okay, did anybody see this month here? Is there anything that looks unusual about it? What is it? It looks like there's 9 days that are missing. Is it 9 or is it No, 11 days that are missing. Can anybody figure out why there are 11 dates missing from this calendar?
The king actually then ordered to change from Julian calendar to Gregorian.
This is a famous month because this is when I will say the Western world changed from the Gregorian calendar, which Pope Gregory, no, I guess it was the Julian calendar, which Julius Caesar had established, to the Gregorian calendar, which I guess Pope Gregory had established. So what was the difference? Calendars, how long is a year? It's not 365 days. You're saying 365 and 1/4. Well, it's not 365 and 1/4. It's 365 and 1/4 and a little bit. And when you add it up over 2,000 years, this added up to about 9 days. And if you kept adding this thing up, suddenly things like when flowers bloomed in Roman times was not the same time that flowers bloomed now, right? So they needed to go and adjust the calendars, and Pope Gregory came up with a new calendar, and if you look at this is what he made the change in September 1752. He eliminated 11 days from the calendar, okay? Supposedly this caused rioting at the time because people thought that the Pope was shortening everybody's life by 9 days, okay? But did everybody see that this is a problem, okay? And that if you were going to try to unify data, okay, calendar issues like this are a problem. What day was George Washington born? You guys have heard of everybody heard of George Washington? Does everybody know that George Washington's birthday is a holiday? Well, it is basically, okay, take that back. It's become President's Day. But when I was growing up, George Washington's birthday was a holiday. And still, it's basically Lincoln's birthday and George Washington's birthday both happened in February. They were both holidays. And they merged them into President's Day because people wanted the holiday in a warmer time of year. Okay? But nonetheless, George Washington's birthday. When was George Washington's birthday? The important thing is it's hard to tell. Okay? Because it depends upon, George Washington was born in 1732. Okay? So was George Washington's birthday the day that, George Washington thought he was born on? Or is it George Washington's birthday under the calendar that you're using? Does everybody kind of see that there's a difference here? Okay? And there are calendar effects like this that happen. This is a particularly dramatic one. But unifying to take care of problems like this is an important issue, okay, if you want to make these things clear. Any questions about that? An example of where these kind of alignments come up that are very important, and very tricky to do, has to do with working on financial time series. So fairly often, what is it that you guys are going to get employed to by? A certain number of you are going to get employed by bank/hedge fund-like companies, and your job might be to try to predict the price of stocks, right? And you could imagine trying to build models here, where here is the stock price each day, and there is some other variable, like let's say the temperature, and you want to try to figure out, can the temperature be used to predict whether the stock market the stocks are going to go up or down? If there's an unusually warm day, does it affect the stock market? That might be the kind of a data analysis you could imagine doing. But recognize one kind of complication that you have is that temperatures are a continuous thing. Every moment of the day there is a temperature. It is not true that every moment of every day is when the stock market is open. And it's not even true that every day the stock market is open. Does everybody see that? Forget about holidays. Notice that there's weird things about weekends. Okay? That during the week, the stock market is closed one night before it opens again. On weekends, it's closed 3 nights. I think it's closed 2 nights before. 3 nights before it opens again. Does everybody agree with that? and trying to, if you wanted to have something correlate with stock prices, do you see that this is now a little tricky? When do you take the other variable from? How many people see what I'm saying? I know this seems a little bit boring maybe, but do people see kind of what I'm saying? If you wanted to plot temperature versus stock price, when is the temperature that you're going to be using? Maybe you'll say, I'm going to use the opening time of the stock market. But what are you going to use as the time for the temperature that you're taking? Okay? Is it different than what you're going to do on a weekend, on a Monday morning? Because maybe if these people were hot all weekend, it behaves differently. Does everybody see that there is a timing difference here? And figuring out what to do with that kind of thing is what I consider to be a cleaning issue. Any questions? One example, I think it was my war story in the book that we had, is we weren't studying temperature on the stock market. That doesn't sound very interesting. But one thing that we were doing that I think it would make sense is news sentiment. So we have systems that we built that would read text in news and determine whether it was good news or bad news, right? And you could imagine a world where you analyze the news overnight, okay? You decide whether it's good news or bad news, and then decide to invest based on whether the news was good or bad. Does everybody get that idea? And so we had a system that, given text, could tell whether it was positive sentiment or not. And we wanted to say, could we use this to predict the stock movement that day? Okay? And this proved to be incredibly difficult to get the experiment right. Why is it? Because we know what time the stock market opens, but how would we know whether a news report was written before or after the stock market opened? Okay, kind of see what my problem is a little bit? You may say, well, what if the time said that was before that? Well, but now I've got to get this thing right across time zones and all these kinds of things, right? And trying to get to the point where you wanted to coordinate. When was it that you knew about the sentiment signal? And when was it that you could trade, and make sure you weren't using news that was old to, that happened after you had the chance to buy the stock, to predict it, right? Any questions? I don't feel I'm being clear about this, but people kind of get that idea? Or any questions about that? So a lot of unification here is making sure you know what time events happened, like when news stories were posted, and being sure that you're only taking news stories that were available to you before they were, basically you wanted to use them. Any questions? Okay, good. One other final, I think, unification that I want to talk about is a lot of stuff that you guys work on will be financial series. There's several issues that come up in unifying, cleaning up data from financial time series, okay? One thing, of course, is that if you're trying to compare prices in different currencies, that's a silly thing to do unless you convert one to the other. Does everybody kind of get that idea? So, I have a price, I want to buy a stock, it's listed in pounds, okay? If I want to know what the price is, I have to convert it, and that price is going to change, the effective value of that price will change with the exchange rate, which changes every minute. Does everybody kind of get that idea? So you need to, if you're going to deal with different currencies, you need to unify them by an appropriate exchange rate. One thing that's interesting is that when you're working with stock data, stock price data, there's certain weird things that happen if you look at stock prices that, if you don't correct for, give you the wrong idea. For example, when a company is successful, has anybody ever heard of a stock split? What is a stock split? Okay, fine. So a stock split is when a company says, my per share price is too high now, people have a hard time buying or thinking about it in that thing, I will have a split, right? Now what happens then to the price of Apple? Let's say Apple, they had a stock split not all that long ago. The stock price of Apple every day, bunk, 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 bunk. What is going to be the stock? Here's where Apple has scheduled the stock split, right? What is the price of a share of Apple going to be the next day? Now, does this mean that Apple has done badly? It means absolutely nothing, really, in terms of the value of Apple, right? So if you're going to be dealing with a stock price series, does everybody see that if you don't correct for a split, listing the price that the stock share sold for each day is a meaningless number? Does everybody agree with that? Okay? Yeah. Okay, so what happens on a stock split? Apple's price may have hit $463, and Tim Cook says, not everybody who wants to buy Apple has $463. So what can we do? We will instead say that we're going to create a new type of Apple shares, or basically, and announce that anybody who had one share as of today, tomorrow has 2 shares of the new shares. Does everybody kind of see that? So let's say it was at 200. Let's make it simple. It was 200. If it was a 2-for-1 split, that day they gave you 2 shares, each of which was worth $100, right? And from then on, when you look at what's the price of Apple in the book, it's going to be $100, right? Now, the price has not dropped in the sense that the value of the company hasn't dropped, right? If you have a program that's doing program trading that says whenever something drops, get out of it, what would you do? You would immediately sell your stock, right? Unless you had cleaned that off to show that that was not a real drop. Any questions about that? A similar thing happens with dividends. I don't know if anybody knows about this, but dividends are when companies pay out some share of their profits to who they own, right? They set a particular time when they say, whoever owns this share by 9 o'clock on Monday, we will give you a dividend. If they pay $3 in dividends to the person who owned it at that time, what is the price of the share going to be a minute later? Okay? It should be $3 less than what it was before. Because let's say that we had a particular moment in time where at this point they were going to give you $3 if you owned it, right? You can imagine that if, let's say there's a certain amount the company is worth independent of that, right? You can imagine that the moment they give, here's the price that it is, the moment before they give me the $3, right? Then a moment I will then get my $3. If I sell my share now, should someone be willing to pay the same amount that they paid right before that? No, because this guy has the share and the $3. After this, that $3 has been sucked out of the company, right? So the price of the share immediately drops by $3. Does everybody see that? Is this a bad thing for the company? No, it's an expected thing, but you want to adjust for that. Any questions? So does everybody see that there's a need to adjust for these kind of things? And a lot of the cleaning problems people get into, okay, a lot of problems when people try to build financial models comes from not cleaning to correct for these kind of data problems. Yeah?
Inherently, the data structure that you have to capture this data, it will not be able to handle this information, right? You need like access, like let's say you have a table which is like stock price versus the company name. So if you have a split, it's not going to capture that.
So you need to somehow clean. Usually what happens is you clean, there's 2 different ways you would clean for that properly. One is to adjust the current price to what it should be based on the old, or you go back and correct all the old prices in terms of the current notion. Okay? But one way or another, this requires special processing. It should be clear that one way or another, this isn't going to happen by magic, right? And that's what the cleaning process is. You understanding your domain, understanding what the problem is, understanding what you want to get from it, okay, and make those corrections. Any questions? The final one that I would like to say that happens with money is there's this notion of time value of money. That if you want to compare money at one point with money at another point, you have to correct for inflation. Does everybody see that? Everybody sort of knows that, but it's very easy to overlook it. Last time when I taught this course, I had one group trying to predict oil prices. And they came by me very excitedly. They said, look at this chart we got, okay? This is over 30 years from 1980 to today. And this shows oil prices over time. And this shows stock prices over time. Okay? See how well they correlate, right? When oil goes up, stocks go up. What was the problem here? Okay? Oil prices are going up all the time. Why is that? Inflation. What about stock prices? Are they going up all the time? They're going up all the time with inflation. I mean, there's up and down movements. But there's everything that when you're comparing prices from 30 years ago to prices from today, if you don't correct for inflation, it's a silly thing. The price of toenail clippers has also done this over time. Does everybody see that? And that this is an example of the kind of a hole a trap you can fall into if you don't think about normalizing it, cleaning it right.
But just in this, I'm just wondering in this case, I mean, if they're both affected by the same thing, wouldn't they share the same percentage of that thing? Wouldn't correcting for it just move them all down 1.03 times or whatever?
No, what I suspect is, for the most part, real oil prices probably move inversely to real stock prices. Is it a good thing for business when oil prices go up? If you're an oil company, you're saying, yeah. But if you're Google, is it good for Google? No, they got to pay more for their self-driving cars, and they got to, it increases expenses, right? So this is, in fact, not what you would expect, that if there was an unusual movement of oil prices up, usually that would mean an inverse reaction to stocks then. Generally, they're both going to increase, right? But what's good for one is not good for the other, right? You would see that if you corrected for inflation, but you wouldn't see that. But that's lost if you don't correct for inflation. Okay? Any questions about that? Okay? So a large part of this is I know on some level this is, lecturing in the point of shaking fingers at people. You got to be careful, and but be aware that these are the kinds of cleaning problems that sink a lot of data projects, more so than, I didn't use the right machine learning algorithm or something like that. It's that they did something stupid when cleaning their data or not cleaning it. Any questions? And so properly thinking through these issues is kind of an important point. Any questions? Okay, good. Now, the other question which I wanted us to deal with here was, how do we deal with missing data? Okay? Fairly often, like in the last data set you had, some of the fields were missing data. Which fields had missing data in it on the world data set? Latitude and longitude. Some of the countries didn't have latitudes and longitudes? One did not, okay? How would you deal which country did not have it? What? Nauru. Okay, Nauru. Okay, does anyone know where Nauru is? What? It's close to Australia, right, actually. They're in the news about refugees. The thing I know about Nauru is it was apparently at one point a very wealthy place because birds would drop on it. It was a place where birds would, in flying from Australia to other places, the only place for a bird to land was there. And apparently over years and years, birds pooped on this island for hundreds of thousands of years, leaving behind fertilizer. And then somebody discovered this, and they, for a long time, strip mined all the fertilizer away. So for a while, Nauru was a very important place. So how do you deal with missing data? I know how I would deal with missing data for Nauru. How would you deal with missing data for the longitude and latitude of Nauru? What? Google, exactly right. That's one that if you really were concerned about that, that's one that you could do by looking up, right? So sometimes there are data that was left out because somebody didn't bother to enter it or there's some other weird thing, right? And sometimes that you can fill in by, by looking, okay? Yeah.
Because our data was quite small, only 190 samples or something. You can Google it if you want, but generally for general purpose, I don't think Googling is the right option because if you have many thousand points missing in your data set.
Okay. If you have many thousand points missing, clearly Google is not the option, okay? If you have one or two, Google is the option, right? So what can we do in general? I mean, there's a couple of different reasons why data might be left out. One is that there was a processing error and it wasn't picked up, okay? Another reason is that somebody didn't have it, actually, okay? It may not even have existed, okay? So there's several reasons why points might have been missing. We agree that in general the answer is not to Google it. What other fields were they? Now, look, longitude and latitude there, it was just Nauru, okay, and we would Google it. What would you?
Land boundaries.
How?
Boundaries, there are many values. Many countries like land boundary values are 0.
Okay, land boundaries were 0, okay?
Now, obviously, any country cannot have a land boundary as 0, so clearly that highlighted that this data was missing.
Okay, so it's how much you with land boundaries. Any other ones that were missing? What was it? Military expenditure, okay? So fair enough. Let's think about it. Now, as I think about that, those seem different to me. Because military expenditure, I don't know how to guess. How about land boundary? Can anybody guess the idea of what land boundary would be? If I had the area of the country, the square root of that is probably something like the land boundary, right? Oh. Okay, let's say we agree maybe it's more complicated than I think. But let me just take a look at these kind of things. That what we should agree with is setting a missing value to 0 is generally wrong, right? Does everybody kind of agree with that? And now for a small island, it's not setting it wrong because if it's Nauru, Nauru is asymptotically equal to 0 in coastline, right? Because it's a tiny place. But in general, when might we have problems? One is when there is data that was never collected. Like one time I encountered was when I needed the year of death for people who were living. Okay? Sometimes there were things that were put in, there was a wrong value that was put in, and it was obviously a wrong value. That would be an outlier, right? Sometimes fields were just left blank because they didn't collect them. And there's another problem which we won't talk about today, I think, but we'll talk about later, where sometimes we have to estimate the frequency of things that are very, very rare, that we may not have seen. For example, what's the probability when I toss a coin, it's going to come up heads? Half. And what's the probability it will come up tails? And what's the probability it will come up landing on its side? Okay, it's not 0, right? Okay, if you've watched, what was it, what movie? Mr. Smith Goes to Washington, it landed on its side, okay? So there are certain events that occur rarely, but is it possible? Is the probability that the coin will land on its head really 0? 0 means nothing. Does anybody believe you that it's impossible for a coin to land on its head? If not, in certain cases you want to estimate those things, right? And sometimes 0 is the wrong answer, okay? Any questions? So I want to talk a little bit about this process of fitting missing data and what we can do. Now, the general thing that you want to do with missing values, if you have enough training records, if you had zillions of countries, okay, then you might want to drop the records that had missing values as being flawed or incomplete or something like that. Okay? Now, in general, is that a good idea or a bad idea? Okay? If you have enough records and some of them are flawed, usually can do away with them. unless what might be a reason why you don't want to throw them out?
I was just going to say, assuming that the record is flawed, I don't see how making up a value that fits within the value you already have adds to the equation, unless it's because you need it for the purposes of an actual technique, like that requires a set value.
Okay. Well, let's still talk about why we might want to do it. First of all, notice that if you have records that are collected from two sources, and one of them didn't collect a particular field, right? You could imagine I send two groups of people into the field asking questions, right? And one guy forgot to ask a particular survey question, right? That would mean that half your data didn't have a missing field there. Is that right? Okay? So it could be that when you throw out records with missing values, you're going to be throwing out records with a particular property. In that case, the property was that one of the interviewers asked the question and the other one didn't, right? Sometimes you will bias your results by throwing out the records with the missing fields, right? If they were missing, so for example, in your case, the records that were missing about military expenditure, what kind of countries were those? Did anybody have a sense? Zimbabwe, what other countries? Nasty dictatorship-like countries and stuff like that. So if you wanted to know about the world, if you threw out all the nasty dictatorship-like countries, you would end up getting a skewed view of the world. Does everybody agree with that? So it's not always the case that you would want to throw out those records, even if you have enough data to do interesting things without it. Does everybody get that idea? So usually I will claim it is good to estimate things, okay, instead of leave them blank. And for many cases, the estimate can be done in a principled way, sometimes the estimate can be done in a principled way based on what you know about the world. So in one data set we were working with on historical figures, we needed to have the death year of people. And so we needed to know what was Justin Bieber's death year going to be. Okay? Do we know that? The answer is not for certainty. Can we make some kind of a guess on that is meaningful? Most likely Justin Bieber will live to be about 80 years old, right? And die in bed surrounded by his loved ones, that kind of thing, right? So better than leaving the death year blank was to impute a reasonable value there, okay? And sometimes this can be done on the basis of your knowledge of the world, right? Any questions? But otherwise, there are other ideas that you might use to try to impute something, okay? So one idea would be to take the mean. So let's say, again, we're now picturing a data set where we have, what you call it, let's do military expenditures. Okay? Now, what would be a good thing to... So now for military expenditures, people have numbers, numbers, numbers. Zimbabwe has nothing here, right? Now the question is, how could we predict what is Zimbabwe's military expenditures, right? One possibility is to replace it by the mean of the column, okay? When is that likely to work well? Okay, a couple ones.
In this case, taking the mean, in my opinion, would be wrong because here in each, there are categories of countries. Like, for example, Zimbabwe is, say, some sort of dictatorship.
Yeah.
If I took the mean, it probably won't reflect Zimbabwe's actual, it might be very skewed from Zimbabwe's actually possible military.
Okay, so if we wanted to predict Zimbabwe's military budget, we agree that, first of all, replacing it by 0 would be very wrong, right? Replacing it by the average military budget of all countries would be better. Does everybody agree with that? It's probably still not great, but it's better, okay? And would be better off doing this maybe by a more principled model. Was this listed in a per capita basis or a total? This is percentage of GDP, okay? So in other words, an average here makes sense for both big countries and small countries, right? If it was listed in dollars, taking the average would be a bad idea, right? taking the average divided by the population or by the GDP would be a better idea, right? So we agree that for Zimbabwe's thing, taking the mean would be better than leaving it as 0, but not as good as we would like, right? Now, one good property of taking the mean, replacing a column by its mean, an unknown value by the mean, is that the average value for that column doesn't change when you do it. Does everybody agree with that? Okay? So that's one good thing, defensible thing about it. Okay? Another idea that is sometimes used, that is actually, will sound ridiculous, but actually has a good, will address the problems that you're worried about. What if instead of replacing it by the mean, we pick a country at random and give that value to Zimbabwe? Okay? So now instead of picking the mean, we randomly pick a country and say, okay, we're going to replace it by the United States one. Oh, we're going to replace it by Nauru's. We're going to do this randomly. Now, why might this be better than picking the mean? Interestingly, on average, an expectation, it will leave the mean unchanged if you do this, which is kind of a nice property to have. But more than that, you can repeat the experiment and see if you end up getting wildly different answers. Or let me take a look at this. Typically, what were you trying to do? You were trying to come up with a score of, let's say, human, some sort of social development for that country, right? What if we impute these numbers and we did a terrible job imputing them? If replacing them by the mean did a terrible thing, we wouldn't have any way of knowing, right? What if we replaced it by random values? We would get a score. Do we have any idea if we did a good job or not? No. But we could now repeat this and do it again with another set of random imputations, right? And see how much the scores change, right? If the rankings between these things didn't change very much, then the imputation didn't probably hurt us, right? If, on the other hand, the scores changed wildly when you did a different random value, then that means that, that there's something wrong there, right? So this gives you a way, by doing this, to figure out the statistical impact of your imputation. Is it really having a big effect or not? If it's having a big effect, then you'd better be sure of your imputation. Any questions about that? The other way to do it, that is actually, I think, generally that I have found to be a good thing, is often you can use some kind of a model to predict the imputation on some kind of a principled way. Like I was telling you, if you want to predict the coastline, the boundary region of a country, knowing what you know about how space works, I still believe that the square root of the area gives you an estimate. You figure, well, let's assume the country is round or assume the country is square, right? More generally, you can build a machine learning model, sort of a regression model, to try to predict what the unknown values are from everything else around it. So what does Zimbabwe look like as a dictatorship? It doesn't specify its military, but there's probably all kinds of other horrible things that are true about Zimbabwe. It would have its leader would have been in power for a long time. Its education level is probably low, okay? And if you now were to build a model by training on all of the other factors, you could probably predict the military expenditure for a country, given all the other things, more accurately than the mean. Does that kind of make sense? So you could imagine building a model to predict missing values, okay, and then replace them by what you had.
Right, so we're not working column-wise, we're working like
record-wise, right. You're going to train on all the records, maybe all the complete records, okay, and try to build a prediction then for what is this field given the complete record, okay? And then that gives you a sensible thing to try with, yeah.
Can you also do something like calculating a distance vector of Zimbabwe with other countries and then imputing it with the value of the nearest country?
Another thing along this line is a nearest neighbor kind of regression scheme. Find what are the 5 countries that are most like Zimbabwe, and then take the average of their military expenditures. That's probably a better way to do it, right? I mean, better. That is better than taking the mean over everything, right?
Yeah.
Maybe. Okay, could be. But does everybody kind of see that this gives you another way to deal with missing things? Either you build a principled model, like my adding 80 to the birth date, or what you call it, thinking of every country as square, okay? Or you build a machine learning thing to train on your data and figure it out from that. Any questions about that? Okay? So if you do these things, you should in principle get better behavior. Yeah?
There has to be some sort of an upper bound on how many missing values we can have in a particular column, right? Because if there are just so many values that we just...
So, again, there's an engineering question. If you have too many missing values on it, one, you might want to throw the record out, okay? Or, again, if you replace the fields by the mean, what's going to stand out are the fields that you have, right? So, in general, again, you have to decide what's garbage and what's not garbage. But as part of the cleaning thing, you should either decide, is this record worth... If the record's so bad it's not worth keeping, you would discard it, okay? Otherwise, maybe you can interpolate and figure it out. Any questions? Yeah?
In exchange to whatever he said regarding that record-wise interpolating and then get a meaningful value.
Yeah.
But what if in the record we have all the uncorrelated values where we can't even guess what's the value that we can put it over there? Like basically, if I don't know about the country, like whether it's a dictatorship or if I assume that it's a normal country like others, still the value is missing. In that sense, putting a mean value is not meaningful. But then even the other values are also uncorrelated.
Okay. A general rule is if you don't want to make any errors, don't make any predictions. Okay? Okay? So if you want to be sure you're not going to make any errors, you can't predict anything, right? But in general, do we believe that in general, in many applications, you will get more sense here doing interpolation for this? I think I can believe that in many applications you can do better, right? Again, if I'm going to send this guy to the gas chambers based on the model that I built, I might want to be more cautious, okay? But that's now a judgment question for you as a modeler. Any questions? Okay, the other cleaning aspect that I'm going to want to just finish up before we go, just to end on this, is outlier detection. So often what happens in your points are that there's sometimes erroneous points in your data that, you want to... It's not that it's that there was something systematic, that something bad that happened when you collected the data. For example, if you look at the study of dinosaurs, you've seen dinosaurs like this, right? These long-necked things, okay? If you look at the database of what is the longest known dinosaur, there was a fossil found that suggested one of these things was 180 feet long, okay? Now, the trouble is that the second longest one that they ever found was 121 feet long. And the question is, why is that? And the reason is, no one can seem to find the fossil that the guy took that was twice as long as anybody else's was. There was presumably some kind of a data entry error when somebody wrote the paper when they said, I found a fossil vertebrae that was 1,500 millimeters long. Okay? A lot of the times outliers correspond to errors. They might be transcription errors, some kind of a measurement error, something that really does not reflect a real data point, right? And so part of the issue that you should be doing when you're data cleaning, in every column, you should look at the maximum and minimum values and decide whether or not they are reasonable values, right? That this dinosaur error that dinosaur someone found claimed to find in 1920 and misfiled the actual bones, okay? That is most likely an outlier because there's such a big gap between it and the one next to it. If things like length and all are supposed to be normally distributed, you shouldn't have big gaps between the biggest and the next biggest, okay? So you need to be suspicious of these things, look at the minimum and maximum, plot the distribution, look for points that seem a lot further out than they should be. Any questions? Now, what do you do when you have an outlier? Okay? A value much bigger or much smaller than what it is. the natural instinct is to delete it, okay, say that record is bad. But often that there is a systematic reason why that mistake was made, and that there's other records in there that also have these kinds of things.